Well, so we are talking about the directly attached storage, DAS. So let's assume this is a server. Okay. Normally, let's assume this is a laptop. Normally, we have the hard disk put inside the laptop. So the hard disk is directly connected to the laptop. This is called your DAS, directly attached storage. So the hard disk is directly attached. It is directly attached. It's called the DAS. The second one is the NAS, network attached storage, meaning you have the same server here, right? How you need some storage capacity to store the data or information, whatever the server wanted to store. Okay, so instead of having the directly connected hard disk, the day one, if you remember, I said there is a data center. Inside the data center, there is something called rack. Okay, rack is of 52 U in size. 52 U equals to 104 inches. Okay, so this height of rack, in this rack, maybe 1/4 or maybe 50% of size, the only hard disks put in place, entirely hard disks. Assume each of these blocks are the hard disks. Hard disk 0, 1, 2, 3, 4, and so on. Okay, assume that each block is an hard disk. So there will be many hard disks as such, not just 4, but there will be many, at least 30, 32 hard disks in each row, and there will be many hard disks. On top of these hard disks, there is an operating system. This is not a Windows or a Linux operating system, but this is a customized Linux distribution, customized operating system. Now, there is a network switch here. Assume that this is a switch. What your server will do is, server will come and connect to this switch, and the server will also connect to this entire hard disks, because the operating system will handle all these hard disks. Now, if this guy needs some 100 GB of storage, what we do is we go to this operating system and we can provision some 100 GB of network files here. This is just like your folder share. I mean, if you guys know about the folder share in Windows operating system, okay, so that's similar to it, but here it is a NAS file share. It is in the NAS system. It is in the a place where you have got bunch of hard disks, dedicated system that is only having the hard disks and an operating system, and your server is connected to these hard disks using your regular Cat5 cables. Now, assume there is one more server. It needs some 500 GB. Okay, so the 500 GB is also connected to the same switch, and the switch has connectivity to this operating system, which has got the bunch of hard disks. And one more server, right? It's like 1000 GB, which is 1 TB. It also has got the connectivity to same switch. This way, there are many servers in hundreds and thousands. Servers will connect to a switch, and from switch, the switch is connected to a rack, a rack full of hard disks, and there is an operating system to handle all these client requests. For example, this guy just need 100 GB, right? So the first 100 GB should not be given to the other guy, or the second 500 GB. Let's say these two blocks together is 500 GB. So this 500 GB should not be given to the other guys, but it is only to this guy. And this 1000 GB is the next two blocks is given to only this guy, and but that should not be given to anybody else. So to do that kind of control, or let's say there is one more guy who only need read-only access on all these volumes. Okay, so this operating system, what it will do is it will help you create shares. Share is just like your folder share, and it will help you to create the permissions, and it will help you to integrate with Active Directory. So what is Active Directory? It is a directory service where you have the users of your company, the entire users and the computers of your company. So if you guys remember from your earlier topic, that is Windows servers or Windows Server roles and features, Active Directory or domain controller is one of the role. If you would have seen there how to install an Active Directory, and if you would have practiced it, giving a domain name, single forest, forest, a first domain controller in the forest, install it, create a test user, give him a different level of permissions, test the practicals, then you would have easily understand now. You, without creating a local users here, you can pull Active Directory user, right, your domain user, and to that user you can say, hey, on share number 1, this guy only have read only access. Share number 2, guy number 2 have got the full access. Share number 3, guy number 3 have got the full access. That way you can actually control the permissions, create the shares, maintain the life cycle activities of the shares. Is that a read write, execute, or only read only? So what kind of permissions you wanted to give, all that is controlled by this operating system. Got it? This is called your NAS. This is called your NAS, network attached storage. So the difference between DAS and NAS was, DAS, the hard disk was directly connected to it. It is directly connected. NAS, the hard disks, the bunch of hard disks are connected to an operating system that is in a dedicated place, and that bunch of hard disks have connected to a network switch so that many number of servers can access that network share and can make use of it. Getting me? Now, why should we go for this remote category is because, let's say if it is a local storage and this guy has the 500 GB, and if he is only using some 100 GB of it and 400 GB is not usable, he cannot give that 400 GB to somebody. Okay, same goes here. If he by mistake, when you're buying the server, if you're buying the server with 1 TB and you're only using 50 GB, you cannot give the remaining 950 GB to somebody else. But guess here, if it is a network share, you can create a share, one more share of 50 GB, and give that 50 GB to this server and take off that 1 TB of space and give that 1 TB to somebody else. So that this centralized approach, the remote storage approach, will definitely help you to a greater extent, and that will help your business as well. That is where these remote storages are getting popular day by day. So in remote storage category, NAS is one of the widely used storage option, and there are few other as well. So you got to know about DAS, you got to know about NAS, network attached storage. There you have SAN, a storage area network. So storage area network is also a remote storage, wherein you have again the same full of rack full of hard disks. It can be full of rack, it can be half size of the rack. You got the operating system, okay, and the same thing here. You've got a switch here. This is a switch, the same topology or the same architecture, like NAS. You have got a client machine. You've got a client machine, one more client machine, and the client machines are connected to the switch here, and the switch is connected to this. Now, you may ask me a question, Venkat, the same diagram you show us for the NAS as well, and the same diagram you're showing for the SAN. What is the difference? Well, as you see the architecture, it is the same, but when you see the equipment, that is different. Okay, so for the SAN, what you need is you need for NAS you need NIC card, Cat 5 or 6 cables, switch, and NAS server, right? The server, the storage system. And for SAN, what you need is HBA. HBA is a replacement to your NIC card. Instead of Cat 5, Cat 6 cables, you need FC cable. Instead of a regular network switch, you need a fiber channel switch, and you need a SAN storage. Okay, SAN storage is the entire rack with the hard disks and an operating system that control or that connect to the SAN. But NAS and SAN are definitely two different things. NAS and SAN are definitely two different things. Now, as you see here, you have the network interface card, which is a NIC card. Replacement to NIC, you have got an HBA card, is host bus adapter. Cat5, Cat6 cable, replacement to which you have got FC cable. You've got a network switch here, replacement to which there is a fiber channel switch. You've got a NAS server here, replacement to which there is a SAN storage. Okay, so this is the component level difference then when you compare the SAN with the NAS. You may ask me a question, when the connectivity, when the topologies, when everything is same, why should we go for SAN? Why, I mean, NAS is sufficient, right? Well, you're correct. NAS is good, but reason that we go for SAN is NAS works on your networking, your TCP/IP protocol, so it gets the file level access, file system level access. It gets you, NAS gives you file system level access, and SAN gives you block level access. So what is the difference between file system and the block level access? Well, the file system level access is, it is more about a file share. If you guys have ever done the folder share, and if you give a folder path to your colleague or to your friend, what he can do is he can access the path, and he can either read the data that is already posted there, or he can put some data over there, right? Maybe a movie or a or music files or photographs or digital files or anything. It can be a Word file, any data, right? When you give a file share, they can put some data over there, or they can read the existing data somebody else put there and you can read it, like the Google Drive, right? What can you do? You can access the Google Drive, you can store some data over there, or you can download some data which is already available there. But can you install an operating system on Google Drive? We cannot. Can you install an operating system on a file share that somebody gave you? No, we cannot. Can you format that Google Drive or the file share that somebody gave? Can we format that with file system of our choice? We cannot do. So that's the reason we go to SAN. The SAN, it is, the benefit is block level access. You will get access to a raw hard disk space, a hard disk without any file system. So you can format it with any kind of file system. All right. So that is the advantage of SAN, and SAN gives you fast or much better performance, and no single point of failure. No single point of failure. Getting me? So it is a block level access. You can, so as it is the block level access, you can format it with any kind of file system that you wanted to. Much better performance. It gives you, when you compare SAN with NAS, it gives you much better performance. And there is no single point of failure, meaning if any one of the component fails, let's say a HBA card failed, there is no failure as such. There is a switch fails, no failure. There is no, I mean, there is somebody else, I mean, something else failed, no failure as such. So HBA, fiber channel cable, fiber channel switch, or a port on the storage system side, that is SAN side, no failure, I mean, no downtime as such. You still can continue to access the storage and can function as you were, right? So that's good thing about the SAN. Those are the benefits using SAN over NAS, but it is costly affair. It is costly to set up. It's not so cheap. It's costly to set up. Okay, so and then it is costly to set up, and not everybody can afford, and not every company can have it. So examples to it is like EMC. There are many VNX series, VMAX series, Extreme IO, which is a flash. Extreme IO. And for NAS, there are like, even for NAS, you have got NetApp, NetApp storage. Even we have something from EMC as well. Those are like the unified storages. So unified means you've got both NAS and SAN in the same system. That's what you're unified. So there are storage, there are storage systems. Those are manufactured by NetApp company, EMC company, both the companies. And there are many other companies as well into it. And there are storage companies, those are into the SAN manufacturing, that is EMC. NetApp also one of the SAN manufacturing company. NetApp. You've got what else? EMC, NetApp, Hitachi. You've got Pure Storage. There are many. There are many in the market. Many, plenty of them. Okay. So the overall idea here is the storage is categorized mainly into local storage, remote storage. The best example for the local storage is DAS, directly attached storage. So directly attached storage, a hard disk is directly attached to your computer. Best example is your personal computer that you have at home and your laptops. A remote storage is like the hard disks are connected on a different storage system. Using a different equipment. So majority of them is like NAS and SAN. So NAS is connected using your Cat5 cables and the equipment that I list down here, and SAN is connecting using the HBA cards, fiber channel cables, fiber channel switch, SAN storage, and everything. So the advantages and disadvantages of them, I list down them, on the bottom side of the page. Yeah, you can see them. Where is the right fit of SAN? Where is the right fit of NAS? Well, companies like the medium scale, small scale, maybe the startup companies who cannot afford to buy this SAN, they were like go for NAS. But the companies like big MNCs, big data centers who need the performance, better performance than the TCO, the total cost of ownership, they will go for SAN, right? So, but at a high level, this is the difference between these are the different storage technologies, that is your NAS, DAS, and SAN. The primary categories are like local storage and the remote storage. Remote storage is like it is remote. You have to connect to the hard disk using your Cat5 cables or your fiber channel cables. So they are called the remote storages. So in the remote, like I said, one works on TCP/IP protocol, the other works on your fiber channel protocol. So it works on your fiber channel protocol, and your NAS works on TCP/IP protocol. TCP/IP protocol. So definitely there is a difference in terms of the performance, in terms of the level of access that you get to the hard disk. Like I said, NAS is like file system access that you'll be getting. In SAN, you'll be getting the block level access so that you can access it and format it with any kind of file system that you wanted. So this is what I know about the storage at a high level. What I'll be doing is I'll be sending you some kind of document, a readable document, so that you can go there and you can read so that you can go there and you can read it. Like you see, the diagrammatical representation of NAS is you got the entire rack that is with the hard disks, and these are connected over the Ethernet. Ethernet is your regular TCP/IP network. The same thing if I go to a SAN, you see, there are different type of operating systems that you got. Each operating system is connected through the different operating systems. You have got Unix, you have got Linux, you have got Windows, you got VMware also, and all these have to connect to a storage area network, which is a special purpose network. Your fiber channel switches, there is at least 2 switches for the purpose of redundancy. That's what I said, no single point of failure. And these cables are fiber channel cables, and of course the fiber channel HBA cards. Let me show you the difference between NIC card and the fiber channel card. When I say NIC card, this is how it looks like. This is a quad port, that is 4-port NIC card, network interface card, and this is a dual port network interface card, and this is a single port network interface card. Okay, and this card is connected through a Cat6 cable, something like this. Okay, this is how it looks like. One end it connects to your network interface card, the other end it go and connect to network switch. So this is how the switch look like, in our home environment, but in the corporate, switches are something like this. So 48 port and even more than that. Okay, so this server come and connect here, and one port, the other port will go and connect to the NAS server that you have got. Let me show you NAS storage. So NAS storage is not something special or anything of that sort, but you have the bunch of hard disks connected in the same rack or tower. You see here there are many hard disks connected to something, and the rear hand side it will go and get connected to your network switch. Okay, this is about your NAS. Let me show you HBA card. HBA. So you see this is something similar to your network interface card, but the ports are different. The ports are not like your network interface card. The ports are definitely different. Okay, as you see here, this is how it looks like, and these are the FC modules that are getting inside it. Let me find a better picture for you. Probably this is something, how it looks like. The cables are different. This is called your fiber channel cable. Okay, so this is your fiber channel cable that is going and getting connected into port to 0 of your dual port HBA card. So this is called HBA, host bus adapter. And you saw this fiber channel cable, you saw the HBA card. Let me show you fiber channel switch. This fiber channel switch is also more or less the same as your network interface card. Sorry, your network switches, but the ports are different because the connectivity is different, right? You see here, these are the ports of your fiber channel switch. It's a Brocade 6510 switch. So that's about your fiber channel switch. And the fiber channel switches, one side it connect to your server, the other side is connect uh, to the SAN storage. So this is how the SAN storage look like. The entire, these are the 3 racks. Okay, so the entire rack is filled with this kind of hard disks. The entire rack is filled with the hard disks. So to control the request to the hard disks, there is an operating system that is customized by all those vendors. If it is a EMC storage, there is a EMC operating system. If it is a NetApp storage, there is a NetApp operating system. So that's something different, but the whole idea is you put hard disks, many hard disks into one single rack, and the rack will go get connect to the fiber channel switch, and the fiber channel switch will connect to your client servers so that you can have them accessed over the fiber channel network. So and then this is the basics of physical storage. So you have a hard disk is connected to the bunch of hard disks is put together in a place. So depending upon the cables that were used, it's called NAS or SAN cables, and of course the operating system, but I'm trying to put as simple as possible to you people. And then so the next topic is the virtual storage. Well, now we will be talking about the VMware topics, because our discussion is, the agenda or our intention is to learn the VMware, not the storage topics of the basic physical storage technologies. Well, I'll talk about what technologies the VMware support, what storage technologies. Like you see, there are like SAN, NAS, or DAS, all that stuff, right? There is something else called iSCSI and FCOE as well, but I really don't want to confuse you with those topics, so I did not talk about them. Okay, iSCSI and FCOE. But yeah, I'll be talking about them. But for now, just understand SAN, NAS, and DAS. These are the three storage technologies uh, that you need to understand. These can be categorized primarily into the local storage and the remote storage. So as the remote storage we talk about, it's NAS and SAN. Local storage, it is DAS. It is directly attached storage. So we will see what storage that VMware supports, basics of ESX storage, where ESX will store the data, basics of virtual machine storage, that your VMDK and the RDM, that like where your virtual machine store the data, and then we will talk about the multipathing. So to start with, VMware supports all 5 storage technologies that we have got. Okay, it will support you DAS, it will support you NAS, it will support you iSCSI, FCOE and all. Okay, so iSCSI and FCOE also fall into the remote storage category. It doesn't fall into the local storage, but it falls into the remote storage category. Now, DAS, NAS, SAN, iSCSI, FCOE are the storage technologies. Of all 5, we understand DAS, NAS and SAN. And now you understand that all 5 storage technologies are supported by VMware. Okay, so first, basics of ESXi storage. Guys, just go back and remember the things. We've talked about the basics of virtualization. Virtualization is like creating a virtual version of something than the real or than the physical. And there are different types of virtualization is what we come across. You got to know there is a desktop virtualization, server operating system virtualization, networking virtualization, um, hardware virtualization. There are different forms of it, and of all that you got to know the server virtualization. So server virtualization is running multiple virtual machines or running multiple operating systems on a same physical hardware at the same time is called the server virtualization. So in that category, what is making it possible to run multiple operating systems is the hypervisor, the virtualization operating system. So that's where we've studied that there are different vendors who support it, like the VMware ESXi, Microsoft Hyper-V, Citrix Xen Server, Linux KVM, Oracle OVM Server, right? That's what we understand. And in that hypervisor category, there are 2 types, type 1, type 2. Type 1 is also called as bare metal. Type 2 is also called as hosted. So we've studied, I mean, since we are learning VMware ESX, which is a market leading virtualization platform, VMware ESXi and ESX both are the type 1 hypervisors, the bare metal operating system, so that they get installed on top of the hardware. Now, what is required to install ESX server, or what is the maximum configuration that supports, that is something we have studied. And we've also studied the differences between ESX and ESXi. After that, as ESX is also an operating system, when you saw the basics of Windows Server 2012 videos and practice, part of which that was 3 parts. Part 1, operating system installation and configuration. Okay, part 2, the networking side of it, where you go configure the network static IP, and if you can have multiple network interfaces, you can team them so that if one of the NIC card fails, the other will continue to work. Okay, the other will continue to work. That's where the RAS functionality come in. If you remember from the basics of physical hardware, what is a server? Server is a piece of hardware that has got the RAS functionality: reliability, availability, serviceability. So as you got 2 network interface cards, that's where the reliability comes in. So when you have 2 network interface cards, your operating system responsibility is to make them as a team, so that if one fails, the other will definitely take care of the failover and it will do a seamless work for you. So the same thing from the Windows operating system is extended to the virtualization. That's where we have the virtual switches created. Okay, different virtual switches, and in each switch you have got different type of connectivity, that is virtual machine connectivity and VM kernel connectivity, and the purpose is different. So that is about your networking side of your Windows operating system. From there, you also have seen the videos, that is the disk configuration. In the disk there is dynamic disk and physical disk. You can create a file system out of it, like your D drive, E drive, F drive, so that we can store some data. While in ESX, here also we need to have some storage options. That's where I said, guys, if you need to be strong at some operating system. So the concepts are same in everywhere. You go to any operating system, go to Mac, Linux, AIX, VMware, Citrix, any operating system. You have the initial operating system configuration, you have the networking configuration, you have storage configuration, you have like the advanced configuration like the security, authentication, LDAP integration. It's a different thing. But at a base, initial configuration, networking, and storage. Now you have probably a chance or a learning opportunity. You can revisit the videos, practice the Windows again, so that earlier if you were understanding 5% of it, now you will understand 20% of it. Next time when you do it, you will definitely reach 50%. And when you do it again, maybe after some time when you got some maturity, then definitely you'll go up to 80% or 75. That's what exactly I need. So this is not something that you can learn in one go or two go. It is a continuous learning. Got it? Now, so ESX also have some kind of storage option. Okay, so when you store something, when you need a container here, obviously, right? In Windows, the container is called a C drive, D drive, all those drives, logical partitions. Here in Windows, the container is called as data store. Data store. So data store is a manageable storage entity usually used as a repository for virtual machine files, including log files, scripts, configuration file, virtual disk file, blah, 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 all that. But in short, a data store is a container that stores the data. That's all. That's all. Data store is a container that stores the data, and it can be compared to your logical partitions in Windows operating system. Now, data store can be of two types. Data store can be of two types. One is your VMFS data store. The other is your NFS data store, NAS. Okay. So what is the difference between NFS and VMFS? Well, NFS is a network file system that is coming from your NAS storage. So what is a NAS storage? You just saw that. What is that? NAS, a bunch of hard disks put somewhere. There is an operating system that is controlling, and you connected to that bunch of hard disks using your TCP/IP network. So it gives you a file level access. So they provision a file system and they give it to you. You access the file system and you can create the virtual machines over there. And the VMFS is a virtual machine file system, which is VMware's proprietary file system. In Windows, you have got FAT. In good old days, FAT32 was a file system. And then we have got NTFS file system. Now the latest one. Okay. So similarly, in Linux, you also have got ext3, which was a old file system, and now we have got ext4. Similarly, VMware also has got its own file system called VMFS, Virtual Machine File System. Okay, so that's the core. My core idea here is to introduce you the VMware file system called VMFS. One shot I can give you the definition, but VMware ESX needs some kind of storage to store the data. It can be your local storage, which is DAS. It can be a remote storage like SAN, NAS, iSCSI, FCOE. Well, in all these storage technologies, there are only two type of data stores that you can connect to the VMware ESX server. One is NAS or NFS data store. The other is the VMFS data store. NAS is just a file system that is coming from the NAS storage system, but the VMFS is the VMware proprietary file system. You can only create a file system when you get a block level access. Now tell me, what storage technologies will give you block level access? DAS or SAN, but not NAS. That's where we've said NAS data stores are something different. So SAN or DAS or iSCSI, FCOE, remaining four storages can give you a block level access, from where you can access the raw hard disk capacity and can format that hard disk capacity with any kind of file system that you wanted to, and can install any kind of operating system. Right? Now we are trying to learn the VMFS file system. VMware vSphere VMFS is a high performance clustered file system, and that is optimized or that is designed for the virtual machines. So while the regular conventional file systems allows only one server to have read-write access, of course, okay, the regular NTFS or FAT or ext3, ext4 file systems can only give read-write access to one server, not multiple. But VMFS file system can let 64 ESX servers access the file system and do read-write operations at the same time. Your VMFS file system can be accessed by 64 ESX servers at the same time. and can let them do read-write operations at the same time. Okay, so here the diagrammatical representation is basically to help you understand from a virtual machine to a hard disk how exactly the what are the layers that are involved. Well, be it a physical or a VM, the IO is encapsulated into a SCSI virtualization called SCSI command, and from there it hits your VMFS file system, and the VMFS file system is actually backed by your volume manager. Okay, and this volume manager is available in all operating systems. But here, since it is a VMFS file system, you have got VMFS volume manager. But if it is an NTFS file system, you will see NTFS volume manager. That's all it is. And then you will get the device access. That is your HBA card, right? And from the HBA card, there is a multi-pathing. I mean, if there are different physical paths to reach to the hard disk, then it will. Like you saw in the SAN, that you at least have two HBA cards and the fiber channels connected to the storage system. So when you have two, definitely there are two physical paths to reach the destination. So this multi-pathing algorithms will help you, which path to use. So that's the idea here. But otherwise, VMware ESXi supports all 5 storage technologies, and if it is making use of NAS, it is called the NAS file system or NFS file system or NAS data store. If it is a VMFS data store, it is called the regular VMFS data store. Well, in VMFS there are two different major versions, that is your VMFS 3 and VMFS 5, and in vSphere 6.5 they have got VMFS 6 as well. Okay, but just forget about VMFS 3. In VMFS 5, what you can remember probably is maximum disk size that you can have is a 64 TB of size. 64 TB of size, and it uses GPT partition table. If you see the earlier one, it is just using, I mean, the maximum size that you can create is 2 TB. That was because you were using the partition style as MBR. So it is not the limitation of VMFS 3, but it was the limitation of your partition table, that was MBR. So that is replaced by GPT. That's why your VMFS 5 can have 64 TB of file system. I mean, a single volume size is 64 TB. Even if you see in Windows 2012 operating system or 2016, a single partition can be of 64 TB. That is because the partition table was replaced by MBR to GPT. That's the only thing. And then the block size is something that you just ignore. In VMFS 5, you just got the unified block size, that is 1 MB. You just ignore it, never mind it. And there is something called RDM, the raw device mapping, which is like we talk about it when you go to the virtual machine level discussions. But the whole idea is to, without creating the VMFS file system, giving the hard disk space direct access to the ESX servers, sorry, to the virtual machines. Okay, so if you give a LUN access to the ESX server, and the ESX server will definitely format it with VMFS file system. But RDM is a concept that what it does is, you will not give access to the ESX server, the hard disk access to the ESX server, or a LUN access to the ESX server, but you will give a direct access to the virtual machines, so that the virtual machines can format the hard disk space with any kind of file system that virtual machines wanted, and can operate the volume. That was the idea. Got it? And then these are like how you gonna use the data stores, like one virtual machine, one data store, or you put all virtual machines into a single data store. It completely depends, but both both ways of implementation is possible. If you have heavy workload applications which need a dedicated one-to-one data stores, then you can probably go for it, but it will create a lot of overhead, and it will create poor resource utilization. But if you go for the consolidation way, well, it's like the pooled resource utilization. You will definitely get, you will see less administration overhead here, and you can effectively utilize the resources as you are putting many of them. Consolidation is much recommended way, because the whole concept of virtualization is to consolidate the workloads and put everything together. The concept of VMDK and RDM is something that we talk about when we go to the virtual machine level topics. But that is all I have for you from the storage standpoint. So all you understand today is like what exactly the storage system is. So storage system is bunch of hard disks put together. Okay, so and those hard disks, depending upon the connectivity that you have, those are called as DAS, NAS, or SAN. And you've seen, you know, extensively what exactly the NAS and SAN is. And when it comes to ESX server level, ESX supports all 5 storage technologies that you have got, but there are only 2 type of data stores. The container is called the data store. Where you store information in VMware, ESX is called the data store. So the data store can be of 2 types. One is NFS data store, the other is VMFS data store. NFS data store is nothing new or nothing specific or nothing groundbreaking technology. If a file share is given from your NAS storage system and that is accessed by your ESX and storing the information, that's called NFS data store. But if you are giving a LUN, right, from your SAN, iSCSI or FCOE, and the LUN is accessed by your ESX server, and it formats the file system with VMFS file system, that's called your VMFS data store. Okay, and then you saw there are 2 ways you can put multiple virtual machines on the same data store on the same container, or you can dedicate one container for one virtual machine, one data store for one virtual machine. It is all about how you wanted to, you know, develop or implement the solution at your environment. So that is all it is for today. I would request you to go through all these basics. I'm going to send you a PDF document, read through it, and we will meet again tomorrow.